Now I want to show you another little trick that we use. We write down something like 2NaSO4. Now what is the difference between this letter or this number here and this number? Well, the difference is that when we write the number down here after the symbol for the element oxygen, the same way that we did in these places, it means that there are 4 oxygen atoms tied up in this molecule. So what does this 2 mean? This 2 means that we have got 2 of the molecules. So it's almost like saying, what is 2A in algebra? It means we've got 2 times A. In this case, we've got 2 molecules of sodium. And what's this SO4 thing called? It's called a sulfate. Sodium sulfate. I'll abbreviate it to sodium sulfate. So if we've got a sodium atom and maybe I should draw the sulfur in yellow, but I haven't got a yellow pen, and so there's my sodium, and it's got 1, 2, 3, 4 oxygens on it. Now that's what a sodium sulfate might look like. If I've got 2 of them, then I should draw another one here, because we've got 2 separate molecules of sodium sulfate. Now, very often we've got names for things that don't bear any resemblance to their chemical composition. Carbon dioxide, it's quite clear to us what carbon dioxide is. A single carbon, 2 oxygens. Carbon monoxide, sulfur trioxide. Water, what does that say to you? It doesn't say anything. It doesn't tell you that water is 2 hydrogens and 1 oxygen. What does ammonia say to you? It doesn't say anything to you. You might know what ammonia is, you might have smelt it in household cleaning goods, but it doesn't tell you anything about it chemically. Ammonium is 1 nitrogen and 3 hydrogens. So you would call it ammonia, but you would write it NH3. You would call it water, but you would write H2O. Another little trick and convention of the way that we write down chemical names. Right, I've written down some compounds here, and we want to see very briefly, and this is where we will end today, how the symbolic representation of various chemical compounds might help us to understand a little bit more about them. Now let's start with these along here. This is called calcium chloride. You see, it's calcium and chlorine, and we get a clue here with this 2 because obviously 2, for some reason, 2 chlorines will link with 1 calcium. Notice again, we call it chloride. When you get chlorine molecules involved in a compound, it will usually take the name chloride. You will never call it calcium chlorine. Now here we name this thing together, and I'm not putting brackets around it, but we get calcium, and I'm shortening that, sulfate. That is something called calcium sulfate. That's plaster of Paris, the kind of stuff that you get put onto your arm when you break it. What am I saying here? Plaster of Paris. Very often these salts have what are called common or trivial names. Here I have something called calcium nitrate. Now the thing to notice here with calcium nitrate is that this NO3 group acts together, but clearly I've got 2 of those groups. So when I put brackets around the NO3, which is a nitrate, when it joins with calcium, it means that there are 2 nitrates joining to calcium, and clearly it also means, although it's not this obvious, calcium needs 2 nitrates to satisfy something about it, whereas it only needs one sulfate. It also means that somehow the nitrate only has sort of one hook available to it to hook onto calcium. Calcium needs two things to hook on it. That means that sulfate must have two hooks. Okay, and calcium also has two hooks. So two hooks satisfy one another. This has two hooks, but nitrate only has one, so we need two nitrates to satisfy one calcium. Now, let's take copper, CuCl. Now, copper also has two hooks, whereas chloride only has one, or the chloride only has one. Now, calcium has two hooks, chloride has one hook, therefore we need two chlorides to satisfy calcium. If copper has two hooks, and I've told you that, then surely CuCl can't be right, because if it was CaCl2, you see it must also be two of these. So two chlorides have 2 times 1 hook, and that satisfies the two hooks of the carbon, of the copper, Cu. Copper sulfate, now CuSO4, that has two hooks, that has two hooks, they satisfy one another. Why did I put brackets around here and a 1? Well, I did so because I made a mistake. I shouldn't have done that. I don't have to put brackets around something when there is only one of those groups in a compound. And I certainly don't have to write down the letter 1 there, because 1, or the number 1, it's understood. Now, calcium has two hooks. Copper has two hooks. Nitrogen has one hook. This can't be right. There must be two of them. It means that I've got a nitrogen and 3 oxygens, and I need another nitrogen and 3 oxygens to satisfy one copper, which I'll put there. So that connects and that connects, because the nitrate and the nitrate, they each have one hook, and copper has two hooks. You'll get a lot more of this when we talk about the chemistry of these different elements. When you get hydrogen connected to something like a nitrate, that gives us an acid, and that is nitric acid.